Hello, and in this recording we're going to be looking at some different behaviors of a function based upon the graph of the function. We're going to look at this particular function. We first of all determined it is a function by looking at the vertical line test. A vertical line crosses through only once anytime we draw that there. So this is a function. We're going to call that function f of x, and we're going to do some questions about that function and its behavior of this graph. Alright, we're going to first of all ask where f of 0 lies on the graph. So f of 0 means that the x value is 0. So that would be this value right here. So f of 0 is looking at this value, but it's asking for the answer, which is this value right here. So f of 0 is equal to 0 here, and f of 6 is looking for where the value is 6 and asking you for the answer, which is the y value here, which is also 0. So both of those are 0 for solutions. Now if we ask where f is 2, that would happen here. So f of 2 must equal -2, and similarly f of -2 is up on this graph right here. Here's -2 on the graph, so the answer is 1 for f of -2. So now it's going to ask you, is it positive or negative? So we look at the value for f of 3. F of 3 would be right around here somewhere. We don't know its value, but we do know that it's going to be a negative value, so the answer to this is negative. Okay. All right. Moving on to some more questions about the graph. It's also going to ask if f of -1 is positive or negative. So in this graph here, f of -1 is right about here. So the value right here is going to be a positive value. So the answer to this is positive. Now this is asking for a reverse question. It's asking for when we know the answer is 0, what is the x value for that? So we're going to look for answers that are 0 here. Here's one. Here's another one. Here's another one. These are all 0 answers. So that means x is going to be several answers here. There's 3 of them that have an answer of 0 for the y value. So in this case, that would be 0, 4, and 6. All right. Moving on to the next question. It says, what values is the function negative? This is less than 0, so it's negative. So what we're doing here is we're looking at an interval. What values of x? So this is an interval where this occurs. So this is negative here. So what we're looking at is on the graph side here, we're looking for when it's less than this line right here, because that's 0 line right here. That's where it's equal to 0. So what we're asking for in number 6 is this interval for this piece right here. So that piece, this interval, starts here and ends here. So that's the piece of the interval that we want for number 6, and that would start at 0 and end at 4. So what we're looking for there is a value from 0 to 4. We can put it in interval notation, 0 to 4. It looks like an ordered pair, or we can use set notation x such that 0 is less than x is less than 4. So there's our set notation, there's our interval notation. Either one of those is correct. All right, moving on to some more questions about this function. It's asking for the domain. The domain of a function is all of the values for the x values of the function. So Our domain would start here at this point and end here at this point. So it runs from this line, that's our x values, to this line on the x values. So our domain is for an interval would be -4 to 6, or in set notation, x is from -4. Now it equals this one, so we use an equal sign, and it also equals 6. On the other one, it did not equal. All right, now the range for a function is the answers. So our highest answer is right here for the range, and our lowest answer is right here. So it ranges in between those values. So an interval for the range would be starting at the low value of -2 and going up to the high value of 3. So the range values are the y values. And if we started looking at that, we would say the y values range from -2 to 3. That would be our range. X-intercepts and y-intercepts. X-intercepts of this graph are where it crosses the x-axis, and we saw that in the other question. That would be, the x-intercepts would be 0, 0, 4, 0, and 6, 0. Okay, and the y-intercept is where it crosses the y-axis, and that would be just this point right here. It only crosses the y there. It doesn't cross again. If it did, it wouldn't be a function. So in this case, 0, 0 is also a y-intercept as well as being the x-intercept because it goes through the origin. All right, now we have a couple more questions about intersecting of lines and the graph of the function. It asks, this one question asks, when does it cross the line y equals -1? Well, the line y equals -1 would be a line through -1 right here, and it would be horizontal through that line. So it looks like if we drew that line y equals -1, it would cross the function twice. And we would do the same thing when it crossed x equals 1. That would be a vertical line. That's a vertical line through 1. So a vertical line through 1 would look like this. 1, and it crosses once there. Okay, and then this one asks, when does the function have a value of 3? We answered that question above, but we're looking for when it's going to be 3. So we're looking at, here's 3 for your answer, and we're looking for when the function has that, and it only has that once. So x equals 5. It may not have it at all, but in this case it does have one answer when that occurs. And when does it equal -2? Also one time. -2 is down here. It goes across, it happens one time. There's a y value of -2. So that would happen at x equals 2. All right, now our final two questions are going to be asking about maximum and minimum values, extrema values, and increasing and decreasing intervals. There are two types of maximum and minimum values. There's the local value, or the relative value, or there's the absolute maximum and minimum values. So in this graph we're going to be looking for both types, local or an absolute. Local has another term which is relative. They can use the word relative as well as local. All right, so we're going to look at this. When we're looking for maximum and minimum values, we're looking for the highest value or the lowest value in its area. So in this case, this looks like a high point to me. It looks like higher than any other point. This would be, I would think this would be a maximum point because it's the highest value in that area. To me, this is also a low point here. That's the lowest point that I see in the whole graph. This is the highest point I see in the whole graph. It's the highest value of y. This is the lowest value. Those would be the absolute maximum and minimum values. So absolute max would be 5, 3, and the absolute minimum is 2, -2. So the value that max takes on is 3, though. So the absolute maximum value is 3. The absolute minimum value is -2. But the minimum point is this point. The value is -2. This is the point. The value for this one is 3. Okay, so there's a couple other points in here that are local. In this point, this it goes up, then it goes down. This is a point that's also what we call a minimum point, but it's a relative or local minimum point. The function goes down to this point. This is the lowest point in its area, so this is going to be a local minimum or a relative minimum. If we travel along this, it goes back up here until it gets to this point. This point is a local maximum because it's not the highest point. 2 is not bigger than 3 here. But it's the highest point in its area. So we have 2 local maximum and minimum points as well. Or I'm sorry, 2 local points that are, one's a max and one's a min. So we have a local maximum point at -4, 2, and its value is 2, and we have a local minimum point at 6, 0, and its value is 0. If they want to know the value of the point. All right. The last question we're going to ask is about intervals of increasing or decreasing. We can see on this graph, if you look from left to right, the function is going down, starting at a local maximum point. We just said that was a maximum point. It decreases, decreases, decreases till it gets to the minimum point. Then it increases, 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 then it decreases again. So there are 2 places where the function is decreasing. It's decreasing in this interval here. It's decreasing here. And it's decreasing here. So we're going to be listing both of those as decreasing intervals. So our decreasing intervals and remember when we do intervals, we're looking for x values here. We'd start at the x value of this lowest value here, so -4, and we went to 2. So our first interval for decreasing is -4 to 2, and we can also write it in set notation. -4 is less than x is less than 2. We don't include the endpoints in these because it's not increasing or decreasing there. It's just has stopped at that point. So we would then also write this interval for increasing or decreasing. So in this value, we would say that that would be from 4 to 6. No, that's 5 to 6. 5 to 6 would be our other interval. Five to 6, and that interval is 5, 6. Now I'm going to just double check on this, and I'll get right back to you. Hold on just a second. Well, I've just checked, and it looks like we will include the intervals instead of not including the intervals. So we would need to change these to include the intervals. So this would be a bracket instead of a parentheses. This would be equal sign here, equal sign, and include the points. So the intervals are going to be closed instead of open. All right, now to finish off this, we have one more interval. We have an increasing interval. Okay, the increasing interval happens when the graph is going up. So in this case, it would be in this section right here. It's going up there, so we're going to look at the x values here. 5 is the high, 2 is the low, so we're going to go from 5 to 2 for increasing. Okay, so that interval is 2 to 5, sorry, going from the low number to the high number, and written it as x notation, set builder notation, we go to less than or equal to x less than or equal to 5, so that we have everything between 2 and 5. So that's increasing and decreasing intervals. We'd look at the graph and also max and minimums.